Hello everyone, welcome to yet another video of electromagnetic fields. In this video we are going to discover an important and interesting topic in electromagnetic fields, which is nothing but gradient, divergence and curl. So before starting to get into the topic, we will discuss about an important operator in the vector calculus, which is nothing but del, or we can call it as nebula. So del can be represented. Del is the vector differential operator. It is denoted by dou by dou x, dou I by dou x. Here I, j, k are the unit vectors. So del can be represented as dou I by dou x, dou j by dou y, and dou k by dou z. If it is an ax vector and ay vector and az vector, if these three are the unit vectors, then we can represent the vector differential operator as del is equal to dou by dou x of ax vector plus dou by dou y of ay vector plus dou by dou z of az vectors. So this notations of using the unit vectors, it varies from author to author. So ijk will be used as unit vectors in certain books, and ax, ay, az, it can also be used as unit vectors in certain books. So it depends on the authors. So this operator is a vector. So the operator, differential operator del, is a vector because we have the unit vectors here, and also it is also known as nebula. Now we will see about gradient. So in general, gradient is an operation performed on a scalar. For example, first we will see in detail about gradient. Gradient is nothing but the gradient is defined and differentiable. For example, let phi of x, y and z be the defined and differentiable at each point x, y and z in certain region of space. Then the gradient of phi is defined by del phi is equal to dou I by dou x plus dou y by dou z j plus dou z by dou by dou z k into phi. So this gradient is taken for the operator. So this gradient is performed on the operator scalar with del. So what is mean by gradient is that, consider a scalar like temperature. Okay, so this scalar value, that is temperature, has only magnitude, but this temperature varies with respect to time from point to point. For example, if you take the temperature around the sun, it will be some at highest point, but gradually the temperature reduces when the heat waves reaches the earth. So the temperature being a scalar, but it gradually reduces in a particular direction with respect to time. So the resultant, it will be a vector, and that is called as temperature gradient. So how to calculate this temperature gradient? We have to perform the gradient operation by multiplying the del with the scalar. Here the scalar is the temperature, so the resultant will be a vector. Now we will see about divergence. Divergence, as the name implies, so the electric field will start from one point, it diverges at a particular point, and then it converges at one point. So the vectors will start from one point and it converge at one point. The resultant will be a magnitude only. So the divergence is performed on a vector with dot product. So divergence is given by del dot v. So the formula is given here. So as of now we have discussed about two topics. One is gradient, which is performed on a scalar only, and then divergence, which is performed on a vector through a dot product. So in the next video we will see about curl in detail. Thank you. Thanks for listening.